Hi all, welcome to my YouTube channel. So in this class, we are going to continue our explanation with the direct band gap and indirect band gap semiconductor. Why we are seeing this much depth means because we need to realistically understand the difference of each topic. So that's why first we have gone through the theoretical explanation. In the last class, we have seen the graphical representation or how the energy band diagram will be. So today we will be seeing the application and just the revise of what we saw in the last class. So like direct band gap, as we discussed, the example is the gallium arsenide. So this is one example for this, the GAAS. So in this case, what will happen is that there will be the net momentum change will be remains unchanged. So the net momentum change will remains unchanged. Momentum change remains unchanged. That's why what will happen? The conserved momentum will be converted into light. So here what will happen? The energy which is be converted to light. So energy which is changed into light. So application of this is the LED and laser. The major application that we have is the LED and laser for the main application. In case of an indirect band gap semiconductor, as we discussed, the normal silicon and germanium will be the best example for this. So in this case, what will happen? The net change in momentum is not remain same. So there will be a the change in momentum is happening because there is no conservation of momentum. So that's why what will happen? The energy which is not converted into photon, which is converted into phonons like heat. So that is converted into heat. So one of the major application here is that it can be used for the diode, BJT, and or other applications of the electronic devices. So diode, BJT, and MOSFET. So all the cases we can use these things. So if we see in this example, each one has its in each benefit. Like if we need to build the application like this one, then please go with this kind of structured semiconductors. If we need this kind of switches or multiplier, amplifier, those things is we need means please go with this kind of application. So there is each one has its clear cut of benefits and each one has its clear cut of application to be used. So this gives a brief understanding of the difference between direct band gap semiconductor and indirect band gap semiconductor. So from this, our classification to the semiconductor comes into N. So next we will be going into the each individual p-type electron contribution, n-type electron contribution in an intrinsic and extrinsic semiconductor. Then we will be starting with the diffusion and a drift current, and they both coming into same existence, how it will act. Then some capacitance effect we will be going to see, and after that we will be seeing some kind of principles and theories in each of the semiconductor properties like Hall effect and those kind of effects also we will be taking into consideration. So from this lecture, I think you guys able to understand all the classification of semiconductor. So up to this, what we have seen is we have seen the clean introduction of the semiconductors. So clear introduction to semiconductor is done. So now you guys will be able to say that you are mastering the basics of semiconductor physics. Then you will be starting to become pro by seeing the next series of lectures. So from here, if you guys have any doubt or any kind of things that I need to clarify, please ping in the comment section. I will for sure put or add another video in order to cover those topics. So if you guys are able to grasp or able to get in the same pace which I am teaching, please feel free to drop your response in the comment section so that I will be changing or modifying the upcoming exercises in the same way. So from next lecture, let's get more deeper dive into electrons and individual hole contribution for the current movement and current and diffusion drift currents also we will be seeing in detail. Like, share and subscribe the channel. Thanks. Stay tuned for the next lecture.